Good morning. This is Scott Edmondson with SF Planning and Christine Ma with Esri to present Enabling Sustainability Success with Regenerative Regional GIS as our GeoDesign Summit session. In this presentation, I'll review our sustainability predicament, describe a 3 innovation antidote, and connect the innovations for success. Humanity's sustainability response stands now at a crossroads. We must shift to an effective approach and scale it quickly or fail. In addition, we must make sufficient progress towards sustainability within 10 years. The 3 ideas of this presentation are as follows. 1, connecting 3 emerging innovations will create the potential for scaling sustainability success in time. 2, this move is our only antidote for our present course. In other words, an accelerating dystopian future of unsustainability. And 3, that GeoDesign is uniquely positioned for this task as a technology and professional practice. The unsustainability antidote's 3 innovations are 1, shifting to a regenerative systems sustainability approach. 2, shifting to 3D geospatial systems planning and design. And 3, developing a global system of regional GIS infrastructure, both the technology and decision process. How to connect these innovations is our challenge. Today, I will sketch the high-level connections that reveal our opportunity, its game-changing value proposition, and how to generate it. In the next sections, I will describe the 3 innovation antidote. Innovation 1. Shifting to regenerative systems sustainability. To begin, we need to clarify the core concept of regenerative. Webster's defines the regeneration function as renewal of a biological system, such as a forest, as a normal process. It is the core dynamic of living systems that recreates life in perpetuity. Next, we need to clarify the concept of regenerative sustainability. In this presentation, I propose that it is the success path from our present sustainability crossroads and predicament, that it is the new approach needed for sustainability success based on redefining our understanding around regeneration as the core principle and redefining our practice to produce real whole system sustainability. If this is true, it is the next big and final sustainability step. A regenerative sustainability approach shifts the focus from silos to systems, from linear to circular material flows, and from problem solving to future designing. This shift connects the human economy and society to the larger living system, not with end-of-pipe impact mitigation as we do now, but at the level of operating principles. This slide summarizes regenerative systems sustainability in terms of key conceptual roots as an innovation in progress and some of the system's performance imperatives that would replace traditional planning goals. It adds up to biosystems mimicry with a design brief that involves a program of innovation and investment to produce the inclusive prosperity needed for 9 billion of us by 2050 and 12 billion by 2100, having only positive environmental impacts. This agenda would restore damaged nature, reverse climate change in time, expand human and natural system productivity, and incidentally, create a global learning society. Fortunately, the innovation required for regenerative sustainability is underway. We do not need to invent it anew. It's bubbling up in our plan, design, and build practices, but we do need to recognize it, grab it, learn it, extend it, and scale it quickly. This slide summarizes regenerative sustainability innovation in practice. In planning, formulating the policies and rules for high-performance settlements. In urban design, adding water and habitat to create high-performance living places. In architecture, prioritizing energy efficiency to enable the renewable energy economy. In landscape architecture, shifting from aesthetics to habitat creation for biodiversity and human health. In utilities, shifting from gray to green urban infrastructure to create living urban and regional metabolism. We're moving from the theory to the global practice lab, with cities now innovating towards regenerative urbanism around the world with bold innovation. We explored the idea in 2 San Francisco planning studies, Living Community Patterns and a Regenerative City Assessment. In this work, we found a transformative regenerative method emerging. It requires changing directions by shifting from doing less bad to doing good by eliminating impacts at their source by design. This approach allows us to enhance both ecological and human economic carrying capacity by design. It transforms linear flows into circular flows that produce no waste and use infinitely regenerated resources by design. Living community patterns are a set of evolving, powerful creativity strategies for regenerative sustainability planning and design. Their power arises from being able to achieve multiple system sustainability imperatives simultaneously. An example is a blue-green street pattern that uses water and habitat for aesthetics, urban activation, and ecosystem services. In addition, this work developed a set of cross-district urban design improvements, district water, biophilic infrastructure, connecting across scales, and circular urban metabolism material flows that produce multiple benefits and in turn build the foundation of the new urban ecological sustainability economy. But most importantly, regenerative sustainability creates a new game-changing value proposition. By recognizing sustainability as an economic challenge, not simply an environmental one, and the built environment as integral to the spatial economy, not simply incidental, our plan, design, and build practices become society's lead agents of sustainability success, economic inclusive prosperity in time. Our profession's value propositions change from a nice-to-have aesthetic value creator that's often value engineered out to a must-have economic value creator of sustainability success, of the sustainability economy that is the necessary material basis for sustainable cities, regions, and planet. As a result, we can now design a win-win future of jobs and the environment for the first time in human history. The key takeaway from all this work is to use all a city region's planning, development, maintenance, and renewal investment decisions with existing budgets to create cities as regenerative life support systems by integrating the performance imperatives into the city metabolism and economy through the built environment and infrastructure. In other words, expend and invest the same resources on regenerative instead of degenerative technology and effects. In this next section, we'll explore Innovation 2, shifting to 3D geospatial systems planning and design, which will create a new powerful practice, digital, object-oriented, urban and regional systems planning, design, and management. The 4 pillars of 3D geospatial systems planning and design are 3D city base maps that create digital twin city region sandboxes for testing, procedural technology that enables automated rule-based digital object-oriented planning and design, interconnected web GIS that enable easy virtual access and collaboration, and automation tools that democratize workflow streamlining and app development. These components enable powerful planning, web and browser-based digital planning and design, whole city object-enabled planning and design, and whole practice workflow automation. Next, Christine Ma will demonstrate ArcGIS Urban. It's a powerful browser-based 3D GIS modeling platform, and it's part of a 3D digital suite of geospatial planning and design tools. Take it away, Christine.
Thanks, Scott. Morning, everyone. My name is Christine Ma, and I'm a member of Esri's Smart City Solutions team. Here, we're looking at San Francisco's ArcGIS Urban model in a web browser in 3D. Urban can interpret and display different versions of a city's digital twin depending on the planner's task at hand, from schematic to satellite to underground views. And what we are seeing here is 3D mesh data from Urban's 3D content partner, near map. In the next few minutes, we will explore how urban can support sustainable system design at 3 scales, from building to neighborhood to the entire city or region. And let's start from the building scale. Urban provides an overview of all the projects in the city's pipeline and labels them by their status. We can then zoom into one project and evaluate its 3D proposals in context, and compare it with the existing condition. The models can be detailed BIM models from Revit or simple SketchUp massing models like what we are seeing here. In addition to integrating existing models from other systems, planners can also create a sketch of the proposal within the scenarios in Urban to better evaluate the project and its impact. For example, here I can set heights for a new building and construct multiple building parts. Each part, node, and edge can be modified individually to create my own design. In addition to buildings, I can also add other design elements like trees, cars, and street furniture like benches and bus stops. And let's add a California walnut tree here. We can then drop down to the street level and compare what's proposed with what's actually on the ground right now. This is yet another angle from which planners can review the proposed scenarios in their real-world context. There are also interactive analysis tools available in Urban, including measure and shadow analysis. One of the latest additions to the analysis tools is line of sight, to understand the obstruction of view from a specific observer point. For example, from the upper floors of this new building to the City Hall and Civic Center Plaza. And this interactive view will better inform the City Council and the public on the design and impact of the project, thereby facilitating the project review process. Next, let's scale out from a building to a neighborhood or a specific plan area, and take a look at how planners can use ArcGIS Urban to create and evaluate rezoning and redevelopment scenarios. Here is a development scenario created and analyzed within Urban for the Mission Bay plan. Urban is able to procedurally generate the plausible building forms on the parcels based on the zoning parameters like height and FAR, as well as building types like mid-rise retail and office. In addition to the 3D visuals, Urban will also generate the impact of the scenarios in terms of housing units, jobs, daily trips, carbon emission, and much more. The dashboard, along with the 3D building forms, help stakeholders visualize and understand the trade-offs between scenarios, helping us to reach a consensus based on economic value as well as environmental factors. Planners can also enable public feedback to allow stakeholders to add comments and feedback aligned to categories that they create for the plan. After the feedback period ends, planners can run further analysis on the geo-enabled comments to help further refine the scenarios. Finally, let's zoom out to the city level and use the indicators in Urban to communicate current status and future trends aggregated from neighborhoods, block groups, or like we see here, transit analysis zones. We can see the dwelling units growth in the city in the TAZ level. This, along with the pop-up and dashboard, helps guide change and measure impact to drive better decision-making. So this is ArcGIS Urban, a web-based planning and modeling system that enables scenario planning, impact analysis, and stakeholder engagement from building a neighborhood to the entire city scale, and explores the interactions among them to plan for a more sustainable future. Thanks.
Thank you, Christine, for that glimpse into next generation 3D GIS digital planning and design that's available now. In this next section, we'll explore Innovation 3, scaling up with regional GIS infrastructure, technology, and decision process. What is the technology of regional GIS infrastructure? It's our familiar desktop GIS, but scaled to the region and interconnected with everything. It creates the translation connectors from the local to regional systems. That creates the local to regional systems integration needed for planning. If we scale regional GIS globally, we create the GIS infrastructure required for the environmental intelligence needed for sustainability success. One of Jack Dangermond's observations is that the global growth of GIS is incidentally establishing a global GIS infrastructure with the potential to be our planetary sensing nervous system, and that it will profoundly transform our capacity to act effectively in the world, locally and globally, if we formally develop it. This geospatial infrastructure is emerging rapidly, providing a rich network of distributed content and capabilities, using modern GIS implementation patterns, leveraging services-based architecture and GIS portals, and advancing 3D GIS analysis and visualization. It is transforming our organizations by integrating and leveraging many technologies. This integration creates geo-enabled systems supporting specialized workflows and applications in our organizations that transform how we work. They, in turn, will allow us to transform our global human footprint and therefore our sustainability and prosperity. Next, we explore the planning and decision process part of regional GIS infrastructure. It's our familiar planning processes connected across scales relevant to decisions. It uses GIS infrastructure technology for environmental intelligence, and it optimizes for the whole system, not the subsystem. 3 examples of planning and decision infrastructure include California's SB 375 sustainability strategies, which are ongoing resourced workflows on a 4-year cycle across all 18 regional councils of government. Another is the UN SDGs and Habitat 3 implementation. A third one is the SCAG Esri Regional Data Platform project that will create the integrated local regional data and services infrastructure that will enable integrated local regional systems planning and decisions. In our final section, we'll connect the innovations for success. Connecting these 3 innovations creates the capacity to scale sustainability success in time. In other words, creating sufficient progress towards sustainability by 2030 so that it's not reversible, it becomes self-generating, and proceeds to ultimate success. The moment of truth. How do we connect these innovations? We start with innovation 1, where we shift to a regenerative sustainability approach to be able to create real system sustainability. Then we combine that with innovation 2, where we shift to 3D geospatial systems modeling to be able to plan regenerative system sustainability. We combine both with innovation 3, where we develop and use regional GIS and sustainability decision infrastructures to be able to scale regenerative system sustainability planning from the building to the neighborhood to the city to the region to the planet in order to produce success in time. For instance, combining the 3 innovations with SB 375 decision infrastructure would create California's state sustainability success in time. And combining them with Habitat 3 SDG sustainability planning decision infrastructure would create global sustainability success in time. Connecting these innovations creates our Sustainability Success Program, our next and final steps to sustainability. Shift to a regenerative sustainability approach, establish the regenerative regional GIS sustainability planning and decision infrastructure, achieve a substantial degree of self-generating regenerative system sustainability by 2030, continuing to ultimate success. Supercharge the process with GeoDesign tools and practices. Lead, use, and extend regenerative regional GIS with GeoDesign to create sustainability success in time by 2030 and ultimately. Thank you for listening to this presentation. What will your next step be towards sustainability success? I will try to launch the Regenerative Regions Initiative and look forward to your ideas. Please email us your questions or comments, and for more information, visit this webpage.